So the first thing that we do with elimination is we analyze those equations. Because now that you know two ways and you're about to learn a third, you're gonna have to make decisions and choose which way is the best. It may be because you like one way more than the other, but I'm hoping that by tomorrow when we work on choosing, you start to realize that sometimes efficiency is important too, because you're on a time, right? So look at what elimination does. Elimination gives us a method to solve when they're in standard form, okay? So that gives you a little more leverage where you don't have to change the equation to be able to solve it. Okay, so look at a couple other things. They're in standard. They're also lined up. Do you notice that the x's are lined up, the y's are lined up, the equals lined up, and the constant? That is important. So the first thing we do is we analyze. The second thing we do is we look and we see, do we see a pair that can cancel out? Because if I go back to our exit ticket from yesterday, look at what it looks like for it to cancel out. What do you notice?
That they have to be the same.
You've got the same number, coefficient, and different signs. So let's call that an inverse pair, okay? So do you see an inverse pair in this problem?
Yes.
What do you see? The fives. See how the fives are both the same coefficient?
One is positive.
So when you have that, you're good to go for elimination. So the next thing you do is you determine, do I add those things together or do I subtract them to get them to cancel? So what I tell students to do is to step to the side of the problem and write it out. -5 plus 5 and -5 minus 5. So this gives me 0 and this gives me 10. Which one cancels it out? The adding, right? So you're going to add the two and make it look like an addition problem. Okay. Now, once you've set it up, you're going to now do the addition. 6 plus 2 is 8x. Cancel. 21 plus -5, 16. X equals 2. Box it in. So now I have X. I need Y. So what do? Plug it into one of the equations. I'm going to make life easy. Pick the bottom one. You could pick either one, but I don't want you on a test taking 5 minutes to decide which equation to plug it in. Just grab the bottom equation, because either one works, and plug it in. So I'm going to take the bottom one, 2x plus 5y equals -5, and I'm going to plug in the 2 for x. So I'm going to get 4 plus 5y equals -5. I'm going to subtract the 4. 5y equals -9. I'm going to divide by the 5, and I'm going to get y equals -9 over 5. And box it in. Am I done? No, because what do I need to do? I need to get the coordinate. That is the answer. So I pause, look for the x. There it is. That one goes first, and then the y. Now, I'm not done teaching you. That is the golden arch of elimination. The equations are exactly like you need them. They just go straight into adding and subtracting. You get your answers easy. But look at the second one. What is different? You don't see an inverse pair. So the first thing you do is you look at the equations and you analyze them. Are they in standard? Yes. Are they lined up? Yes. Now, do I see an inverse pair? No. This is where you make a choice. Do I change the equations and go to substitution? Or do I change the equations and go for elimination?
Change the equation, go for elimination.
So since we're working on elimination, that's where we're going. So let's do it through elimination. I'm going to look at the two equations. And I'm going to look at each pair. So this is a pair and this is a pair. I need to pick a pair that either has a common factor or when multiplied together, divide into a common factor. So would I want to pick 2 and 4 or 7 and 2?
2 and 4.
2 and 4, right? Because what would I have to do to the 2 to make it 4?
You gotta add.
Multiply it by 2, and then I would have 2 of the same integers, right? Sometimes you have to decide, do I go higher or go for the smallest factor? And a lot of times, and all the times, what you're doing is you're going up. You're always multiplying to the integer that needs to be bigger. So this is what you do. You take the top equation and you distribute a 2 through the whole thing. Because you're going to force it to have the same integer. So I'm going to get negative 4x plus 14y equals 10. And then I'm going to write the second equation underneath it all lined up. Now, do you see an inverse pair? Yes. So I decide, do I add or subtract? I don't guess like you just did. I go to the right and I add them and I subtract them. And which one gives me 0? Add. So I'm going to add both like this. So now this cancels. I get 12y equals 24. Y equals 2. I have y, so what do? I pick the bottom equation and I plug in the y. 4x minus 2 times 2 equals 14. So I get 4x minus 4 equals 14. Plus 4, 4x equals 18, divide by 4, x equals 9 over 2. Now what? Coordinate. So I pause, I find my x, I write it first, and then my other one. And I'm okay with the improper. I'm not changing it to a decimal. They did not ask me to do that. And 9 over 2 is a perfectly good answer.